Hello class, today we're looking at two terms, ions and isotopes. These are the 5 questions you need to be able to answer. Define ion. 2, when does an atom become an ion and why does an atom become an ion? 3, define isotope. 4, how do we know if an atom is an isotope? And 5, what is a common characteristic of an isotope? All right, so today's two terms are ions and isotopes. And they're very important in understanding how we draw atoms. Ions are going to give up or take electrons, and in an ionic bond, we will get to that in chapter 5, atoms have given up or taken their electrons to become stable. Isotopes have more mass usually than the original or the normal version of that particular element, and so we'll talk about how that mass is added. So first we're going to look at ions, and ions just means that it has lost or gained an electron or more than one electron. Lost or gained electrons. So the whole purpose, why does this happen, is to become stable. And to become stable, they have to have 8 outer electrons. So if an atom only has 1 outer electron, it will generally give away that electron. Because it's easier to give away 1 than to try and bring on 7 to get to 8 outer electrons. So generally, the way we can look at this is if we have an atom like lithium and it has 1 outer electron, if we draw our dot diagram like we've been practicing, then it will generally want to give that electron away. And when it does, it drops down an energy level and has a full energy level right before that. If we have something like chlorine, chlorine has 7 outer electrons, and it will generally want to bring in 1 more. It's easier to bring in 1 than to try and give away 7. So it will try to bring in 1 electron. So we have 2 types of ions. We have cations, which are positive ions. And what happens in positive ions is that they lose their electron or more than 1 electron. So this is our example of that. Lithium will try and give away its 1 electron. And we have the word anion, and an anion is a negative ion. It gains electrons and becomes negative. So that is our example here. It gained an electron and it became negative. Now a lot of people think, okay, if I give away something, then that would be negative. But we're looking at our number of protons and electrons. So for lithium, lithium has 3 protons and 3 electrons. But if it gives away one of its electrons, it'll then have 2 electrons, and now it's a positive ion. It has an extra proton, so now it's positive. If we have chlorine, which has 17 protons and 17 electrons, and it brings in 1 more electron, it'll now be at 18, which means it now has 1 extra negative, and that would be a negative ion. Somebody in a past class had referenced this as if you are trying to lose weight. So you lose a pound, that's positive. If you gain a pound, that's negative. Might help you. If it doesn't help you, don't worry about that. But you do need to know the difference in when one becomes positive or when one becomes negative. Our next term is isotope. And an isotope just has a different number of neutrons than is normal. So our mass comes from protons plus neutrons. If we were to look at an isotope, it would have a different mass than is normal, and that normal is usually on the periodic table. So protons can never change. Proton number never changes for an element. That is its identity, if you remember that from yesterday. The proton number is an element's identity. But the mass can still change if our neutrons change. So the number of neutrons, if they are different, they are called an isotope. And usually they are radioactive. They don't have to be, but most often they are radioactive. So some purposes for isotopes: cancer treatment, preserving foods. And then one example here is hydrogen. Hydrogen has 3 different versions of itself. In this one, it's called a light hydrogen, H1. There's no neutrons, 0 neutrons. In this one, deuterium, there's 1 neutron. And then here, tritium, there's 2 neutrons. Just to show you an example. You don't have to draw those, but just to show you how the mass can change. In carbon-12, normally there's 6 neutrons. In carbon-13, which is also stable, but there's 7 neutrons. And in carbon-14, that one is radioactive, and there's 8 neutrons. So you can see how the mass would change. Notice the number of protons stays the same in each version, but the neutrons change, which changes its mass. That is a review over ions and isotopes.